let's talk lab equipment. So as I'm cleaning up from 5 years worth of experiments, while simultaneously carrying out some last minute experiments because some cool stuff popped out.
Xin chào anh chị em, thì hôm nay chúng ta sẽ cùng nhau đi tham quan trực tiếp phòng thí nghiệm cùng chị Pipette. Thì chắc các bạn còn nhớ là trong video trước, chị Pipette đã giới thiệu các loại dụng cụ và thiết bị cho phòng thí nghiệm, nhưng đó là hình ảnh trên slide. Thì hôm nay chúng ta sẽ cùng nhau đi thực nghiệm một vòng trong phòng thí nghiệm quái sinh ở bên bển á, xem nó có những cái thiết bị gì nha. Video này tôi đã nhịn ăn nhưng vẫn ngủ đủ giấc để làm phụ đề. Nếu bạn thấy hay thì hãy follow kênh và chia sẻ video nha. Rồi, bây giờ chúng ta cùng nhau xem video nào.
And so I wanted to reboot an old post, refresh it, extend it, give you information that's going to equip you for experiments in biochemistry, so that you know what's what in a biochemistry lab. So some stuff I forgot before, like how could I count out the timer, which right now is telling me that I have 26 minutes until my next step. So let's get started. But yeah, seriously, timers are so undervalued. And so one of the greatest things I got was this timer. It's like multi-channel, and then it also like counts up and down. The only thing I want is I really want a timer that has like a 5-second countdown or something before you press the button and then it counts down like 5, 4, 3, 2, 1, and then you start. Because how are you supposed to like simultaneously hold the tube and pipette and press start at the same time? I don't have enough hands for that. Yeah. So if anyone's listening that makes these timers, pretty please, thanks. Okay, let's talk. Of course, one of the most important things are pipettes. So these are, when we talk about pipettes in a biochemistry lab or a molecular biology lab, you're usually talking about these like micropipetters. So they come in different sizes with different amounts of liquid, and then they have different tip sizes that go into them, and then you suck up liquid and push it out. Yeah, so we tend to refer to them by their sizes. So like this one goes from 20 to 200 microliters, and we call it like a P200. So this one goes to 20, we call it a P20. This one goes to 10, we call it a P10. And this one goes to 1,000, we call it a P1000. So 1,000 microliters is 1 milliliter. In addition to like normal micropipettes, we have multi-channels and we have repeater pipettes. So a repeater pipette is going to go, you set it for a fixed volume, and then you suck up you suck up once, which has like way more than you want. Then it'll be like the first one, don't trust the first one, it's going to get it to like the right point. And then after that, each of the ones should be the correct volume. They come in different sizes, with each of them has like limited volumes that it can actually go. I think probably the newer ones have more, like you can have more control over them. But this is really great for when you're making a lot of aliquots. A multi-channel is really great when you have a bunch of like, you want to suck up the same thing and put it in put the same thing in lots of different wells. Or even if it doesn't have to be the same thing. So if you want to use the same thing, you can use one of these like dishes that'll hold the liquid. And if you want to put different things in, then you could have them in like a PCR strip or in a block, and then transfer out of that and into where you want to put them. And again, these come in a lot of different sizes, but know that the tips that you use for these are typically different than the tips that you would use for other things. That you have to make sure that the tips you're using are compatible. Speaking of tips, so these, in addition to like these normal micropipette tips, we have filter tips. We use these when we're working with RNA and when we're working with radioactivity. So they have a filter here that's going to prevent things from going from the pipette, like from the tip or whatever, like before the actual end of the pipette, like the solid part before you put the tip on. That part can get like contaminated and stuff and have dust and grime and RNAs potentially. And so then when you go to pipette something, you want to make sure that your sample, you're not like pushing things out into your sample. And so the filter is going to prevent that. And this is really important when you're working with RNA, and you have to make sure that no like RNAs is getting in there, which should then chew up your RNA. When you're working with radioactivity, you want to make sure that you're not like over sucking up the stuff and getting it onto the pipette. And so then the filter is working kind of to keep things out the opposite direction. But either way, you should never actually come into contact with the filter. It's just kind of like a backup, but your thing should never go that high. when you have a lot of samples, then we have things like the mosquito and the liquidator. And so mosquito does really tiny volumes for like these crystal screens. This is one of those like 96 well dishes with these little holes. Then we also have this like liquidator. This is a liquidator. This is really helpful for when you're setting up crystal screens. It does like does a whole block of pipette tips at once. So you put in like one of these trays and it'll pick it up and it'll let you do a whole block at once. This is really good if you have like doing crystal screens to try to find the right conditions and you have this block with this each of these wells is like a different mix of buffer and salt and various additives, and you want to test it to like the same protein in all of these things. Then you could take this and then you could transfer it and you could do this. So they often sell like custom, you can buy like standard screens or you can make custom screens and then they'll be in a block and then you can transfer it over. It's our formula matrix. It's really cool. You put in little bottles and it'll make up custom formulas and make crystal screens. So really cool stuff if you want like to customize the conditions that you're testing. This is really helpful. This is like an automated version of this where it actually will like mix and it'll do like specific volumes. This thing is really awesome and it saved me a lot when I was doing tons of assays where I needed to like transfer a bunch of stuff. So this is another type of pipette. So this is a pipette man. So this guy like actually sucks up like bigger amounts usually. And we have these different size of like sticky pipette things that go in here. And then we can suck up liquid and push it out. And so we use this for like larger volumes of liquid. This thing is super helpful. So basically it replaces like bulby things like this and other type of bulby things that themselves replace mouth pipetting, which is literally what it sounds like. People would like suck up liquid through pipettes, which is super dangerous and not a good thing to do. Other types of pipettes, so you have these like Pasteur pipettes, which are glass. We use these a lot for like when we're doing pH balancing, small amounts of like acid or base. A transfer pipette, which are good for when you don't really need to be exact, but you just want to like squirt things from one place to another. So these are Hamilton syringes. Hamilton's another brand name. But these are these glass syringes, really helpful for when you're injecting into like an ACTA for a size exclusion chromatography. We have a bunch of different sizes. So this is like 250 microliters. We also have, this is 100 microliters. We have like 250, we have 500, we have 2.5. Some of them, like especially for the bigger sizes, that you have to actually put in put the needle onto the end. And you can also put these needles onto like one of these plastic Lear lock syringes. These are the syringes you often use with like those little like disposable needles, but these aren't as sharp and these are reusable. They're metal. It's important to wash them afterwards, like squirt water through it, that sort of thing, so that nothing gets clogged in there. And they also have like a little metal tool that you can use if something does get clogged in there. I'm not sure exactly where. I think it's in here somewhere. Yeah, there's like these cleaning wires that you can then stick through if something gets stuck, but try to avoid things getting stuck in the first place. The real stuff that makes a lab run is all of like the bottles and flasks and various things. And so we have all sorts of different types. So these are like those pipettes that I was talking about before. We have like different sizes that you hook up to the pipette man. These are like, we have plastic bottles for when we're spitting down cells. We have all sorts of graduated cylinders. So basically like you want to use the smallest one that you can that will still like hold the volume, because the lines between them, like if you're on like a huge one, then the line, like each of the lines or whatever between them, they're like a bigger volume separate them. Basically you can't measure as fine a distance between things as accurately, but we have graduated cylinders of all sizes. Then we have Erlenmeyer flasks, which those lines and the lines on the beakers, these are just like approximate lines, so you don't want to be actually like measuring with these, but they're really great for when you're doing things like dissolving salts or whatever in solutions, and then you so you dissolve them in one of these with like a stir bar on your plate, and then after it's all dissolved, you pour it into a graduated cylinder and add volume to the actual line. The ones on like the beakers are approximate, and the ones on the flasks are approximate. Even the ones on the graduated cylinders are still like, they're not perfect. If you want like super precise, there are things like volumetric flasks you'll use a lot in chemistry. We don't use them as much really in biochemistry because we don't need to be that precise. But these, so you'll see like with the graduated cylinder, you have all those different options for different volumes that you want. With a volumetric flask, you only get like a single volume. So you have like a 1,000 one, you'll have like 100 one or whatever. So there's different sizes, but they're for different specific set volumes, and they have like this single line. So you can see that like they have this big flask part, and then they have this narrower stem, and this line is like calculated to be super like calibrated to be super precise. So if it's at the line, it'll be exact. Plus or minus 0.3 mils for this. So that's pretty good. And remember when you're measuring, you want to you measure from the meniscus. So if you're looking at it like straight on, the water, because the liquid, it's going to kind of curl up the sides, because it's really sticky, so the water like sticks onto the surface, and it kind of like pulls up as it's dragging along the surface. Because it's like attracted to the surface and it's pulling up, and then it's pulling the water with it, the rest of the water with it, because the water is attracted to it. Other water, so basically that's why you get like that meniscus. And so you want to go from the bottom of the meniscus should be on the line. So like if you have my chin was the meniscus, I'd want the chin to be on the line, measure like that. So these are our Pyrex bottles. So just like a quick thing to keep an eye on is these should have this plastic ring. A lot of times the plastic ring comes off and then they don't seal as well. Another thing is that like sometimes if you autoclave them a lot, which I'll talk about the autoclave in a second, they get all crusty like this, and then it can actually like the crusty stuff like falls into your bottle, and it's really annoying, especially if you had just filtered it. And yeah, so that is something to keep an eye out on. And so and also watch out for cracks and stuff, which are really going to impact when you're trying to do like a vacuum filter. So this is what I was talking about before. This goes on the top of those bottles. And so it has like one of these, and you put a filter on top, and this goes like this, and then you screw it on, and then the vacuum pulls it through. But you're not going to get a good suction if there is a hole, if there's like a crack in the lid or whatever, and so be careful about that. But you don't always have to filter your solutions, but I tend to just like always filter my solutions. So I use this like vacuum filter. So it comes in like these 3 pieces. So you have this part, you have this part, and you have this part. And this is like a reusable one. And so basically this part, it has this like rubber gasket. Make sure it has the rubber gasket on it. Like we had our old rubber gaskets, they like broke, and then apparently you can't just like buy the rubber gaskets, so we had like our machine shop make it rubber gaskets, but then they're a little too big, and so then it's kind of like hard to get the right seal. But this part screws on, then this goes in here, and then you have to put your membrane on top, so that's actually going to do the filtering. And so this part is like single use, and so these are like nitrocellulose membranes. These are like 0.2 micromolar or micrometer. See, I always like just default to molar when I see a micromolar. Okay, but anyway, and then this base part, so you want to hold down the base. This is hard to do like one-handed, but you want to hold down the base before you screw it on, or else, as you see, this isn't going to be tight, even though this bottom part might be tight. You want the whole thing to be tight. Okay, okay. So now this whole thing is tight. Then I can hook it up to the vacuum line. See, I already filtered this morning, so that's why I have this it's already gone. But this goes in here, And then when you turn the vacuum on, you'll hear the noise. And then typically what I do is I pour a little of the liquid in to make sure it goes through nicely and the vacuum's all good, and then pour it in and filter it completely. So I did a little just to make sure it was right, and now I can pour it all in, and it's filtering through the membrane. For instances where we need to be like super sterile, and we are like for like tissue culture and that sort of thing, or when we're filtering our like insect cell, like our V1, so big cell, like insect cell viruses for protein expression, we'll use these like vacuum filter units that come like, they're like pre-sterilized and stuff, and they're like single use, and yeah, so they can screw on to the other bottles as well, but they also have to come with like a little bottom attached, and so it works the same as those others. They're just like single use, pre-sterilized. For some solutions when you don't have as much volume, then what I use is I can do a syringe filter. So we have a syringe, you pull up your liquid, and then use a filter. So we have different size filters for these. So typically when I'm doing like an antibiotic or something like that, when I'm just doing a smaller portion, I do like a 0.2 filter. So it's good to use, like I typically use the 0.2 filters for various like little solutions, whatever. And then now we can talk about tubes. So these are Falcon tubes. Falcon is like a brand name, I think, but everyone just calls them Falcon tubes usually. So they have this like conical bottom, which makes them good for like centrifuging and stuff, but bad for when you like want to hold it up because it just falls down. So then we have racks which can hold them and stuff. So this is a 50 milliliter. This is a 15. Yeah, I make little like recycle like lab boxes and stuff to make things for my bench that'll hold stuff and be really handy. So those, but probably the tube that we use the most often is the Eppendorf, which Eppendorf is another brand name, but it's this microcentrifuge tube, which they usually hold about like 1.8 milliliters. And so if you think this thing is small, wait till you see the PCR strip tubes. So this is for PCR, which we talked about, which is that method to copy lots of DNA in the machine. So these tubes are a lot smaller. I think they're like 0.2 milliliters, which would be 200 microliters for if you're trying to put that into perspective for the pipettes we talked about earlier. In addition to like tubes, we have blocks. So these like deep well blocks. There's also blocks with like more narrow, or I guess those would be more like plates where they have little tiny brown holes. But these deep well blocks are really handy. So for like in the ACTA, so when we're purifying proteins, we can collect the fractions in one of these. These are like cluster tube strips. These are really helpful for experiments. They have these like strips there's like eight tubes per strip. So kind of like a PCR tube, except they're bigger and they are like the wells of these plates, but you can take them out. And so these are really handy when you're doing an experiment where you have a lot of samples and you want to use like a multi-channel pipette and that sort of thing, but then you need to take them out and do it something with that. So I'd use these for a lot for like slop lots and stuff, more on those in other posts. But yeah, so the bad thing about when you're using like a block or whatever, it can be really hard to tell the wells apart. So I like to color code things so I don't get lost along the way. Oh, I can't forget to show you parafilm, which is like the world's greatest thing. So parafilm is kind of like this waxy, thick, like cellophane type stuff. You can stretch it out a lot and you can use it to like wrap around the edges of tubes or petri dishes or stuff that you don't want things to leak into or out of, and it's really, really fun to play with and really, really awesome and lasts like forever. And these are just a little tip. This is really handy for doing like making a PCR strip tube rack. Is you take the tip racks, like for these tip boxes, they usually come in like trays. Sometimes they come in like just bags and you have to fill them yourself, which is what I did in underground. But here we have them come in these trays. And so when you replace the tray, then you're left with like an empty rack. And so you can put a couple of them together and tape them, and it makes a really good holder. I was going through all my boxes and I was too afraid to throw this stuff out. Yeah, so I gave it a day and then I'll throw it out. But I have a bunch of old primers and stuff. That's why I have this weird bin here. But what I wanted to show you from here was we have these cool blocks. These are like chill blocks. So what you do is you freeze these, and then it's like an ice block, but it's like not icy, and you have these racks and stuff, and so you can stick tubes in here and keep them cold while you're working. Super duper helpful when I'm trying to like organize a bunch of these tubes that try to put them in numerical order when they're all over the place. So this is really helpful. This one also good for like setting up qPCR and stuff. These plates, these ones like change color when they cool typically, so that you know that you need to stick them back in the freezer. We have a variety of heat blocks. So like this one is really convenient for when you are preparing like SDS page samples and you need to boil the sample first. And especially if you're using your samples have potassium in them, that's going to precipitate out with the SDS. And so you want to like take it straight from the heating block onto your gel, or else it's going to precipitate and be all gross. And so it's nice having the block right there conveniently. So we typically leave these like set at a single temperature. And then if we want more complex things, we have these incubators where they can actually, this one can actually shake, or I guess they both can shake, and they can take different size lids. So this one's like a PCR. This one has like a PCR plate, and it has an adapter so you can stick on like so those are kind of like more updated versions of this one, but this one still does the trick for when we're just doing like small bacterial cultures, such as like a recovery after transformation. So we have these little like pulse spin centrifuges. So centrifuges is another super important thing. So a centrifuge is basically something that spins really fast, and this is where like the conical comes in handy, because you can like pellet out things and then they'll stick to the very bottom and you can suck out the liquid from above. So this is like a pulse centrifuge. So it's just like a little lab bench one you can use when you want to spin things really quickly. But then if you want to actually like spin things more controlledly and for a longer time and faster, you have like benchtop centrifuges like this. So the tubes go in there, that's this lid. And then you can set the settings for how fast you want it to go and for how long. This one actually has like a refrigeration too, but not all centrifuges do. We also have a lot bigger centrifuges that I'll get to in a little bit. But moving this way, this is our water bath. So we use this a lot for thawing cell pellets, and for doing transformations, which is where you like heat shock to get bacteria to take in a plasmid DNA that you want them to take in. And so this is at the end of my bench, and so I often think that people are coming to see me when really they're just coming to do the transformations. So I get very confused because I seem very popular, but really it's just the water bath. The water bath also makes really loud growling noises when it's running low on water. So if you see that happen somewhere, fill the water so that people don't go crazy. Okay, so now let's go see those bigger centrifuges. So this is like a benchtop one. This one is really good for like spinning down mini preps and protein concentrating. I have oodles and oodles of spin concentrators. So I talk about this in another post, but basically they come in these different sizes with these membranes with different molecular weight cutoffs. Things bigger than that cutoff will stay inside and not go through the membrane, but the smaller stuff's going to come out, and so that's going to let you like concentrate your protein. It's swinging bucket, so it has these different like adapters you can put in for different sizes of tubes or plates. If you're wondering, sometimes there's like weird looking like wrench tools or whatever next to a centrifuge. those are probably to actually like change out the rotors. So you just like unscrew them in the center and then you can swap out. So if you want to put like plates in there versus tubes and that sort of thing. And then we have even bigger centrifuges in our centrifuge room. So yeah, so we use these when we're spinning down like liters of cell culture. So these are more swinging buckets. And then we also have these ultra centrifuges, which go super, super, super fast. And those are really good for when you're trying to, like once you've broken open cells and you want to spin down like to separate the soluble stuff from the membrane gunk. It's really good. And so these use these fixed rotor adapters, so the tubes are held in a fixed position, unlike the swinging bucket. One thing I forgot to say when we were talking about the centrifuges is, so we keep those rotors, if you wonder why I was like going back behind the door before, we keep the rotors, like the fixed angle rotors, in the fridge so that they're already cooled and we don't have to worry about like pre-cooling them down. For these big centrifuges, you want to keep, if you're not using it, you want to keep it open but off. If you keep it open but on, it's going to try to cool down. If it's like set for like 4 degrees Celsius or whatever we normally set it at, it's going to try to keep it cooling down, and then it's going to cause all these problems and you'll get condensation and you're wasting a bunch of energy and stuff. So that's not good. We also have another thing you might see is like shakers for doing like cell growth in little tubes. Like after you do transformation, you're trying to let the cells recover. We have this benchtop shaker. We use that when we're doing like overnight, like 5 mil cultures, such as for our mini preps. And then when we want to scale up our expression, then we use bigger flasks in this bigger shaker incubator, which isn't on now, but it can hold a lot of the like 2-liter flasks or so. And you adjust the temperature to what you want it. This is our cell culture room, and so these are more shaker incubators, but these ones we use for insect cells. We also have incubators that we can use for like mammalian cells, and what these ones have in difference is that they actually control the CO2 because the mammalian cells are sensitive to that sort of thing. Then we have our culture hoods where we do our sterile work. This is a Vortex. So basically you stick your finger, you don't usually stick your finger, but you stick something on here and it'll vortex, so it like mixes it up really well. We also, in addition to having like a hot dog roller, we have this like orbital shaker where it's going to go like, we have a platform rocker where it's going to go. This is good for when you're like staining and destaining gels. Sometimes we have this like end over end rotator. You can they have it this way so that you can stick in little Eppendorf tubes in between here. I also like tape on like longer Falcon tubes onto the side, just like tape around it. There's also, you might hear of like a nutator. That's like something that kind of wavy, like circle-y motion type things. We don't have one, or I would show you, but if you hear that term, it's kind of circling, but going up and down. It's cool. This is a spectroscoper. Is that the word? So basically, you stick your little cuvette in here, and it measures how much light goes through different wavelengths. And that can tell you, like, you can use it for like Bradford and stuff to get protein concentrations, or if you want to do it with bacterial cells to get like how much they've grown and stuff. This is a NanoDrop, which is a similar type of thing, but it uses a tiny little drop, so you don't use as much sample. We also have a lot of other stuff like freezers. So this is like a -20 freezer, and these are our -80s, which we use for like long-term storage of sensitive things like proteins. So those are really, really cold. We have dry ice delivered like frequently. So we get it in like these blocks. This is really helpful for when you're shipping things or when you need to keep things cold and not all wet and soggy and cold for longer and stuff. Speaking of cold, ice buckets are a hot commodity, pun intended there. But we use ice buckets a lot and a lot of ice because we like to keep our things cold and happy and not degrading. But remember that ice does melt, and you might think that's pretty obvious, but there are so many times when there's just like, you see people's ice buckets with like tubes in it, just like floating in the melted ice. So yeah, be careful, and remember at the end of the day to make sure you have taken everything out of the ice buckets. But yeah, here's an example when I'm doing my cleaning out. I have like this, I put some dry ice in like a styrofoam box so that I could work when I'm trying to go through all of my old stuff without like thawing it all. This is our liquid nitrogen doer, a small one, so we can hold liquid nitrogen if we want to like flash freeze samples. We also have storage tanks where we can keep, if we have like crystals that we want to store before shipping, we can keep them in like a storage doer. We have these, basically we have racks that we can then hold these pucks, which hold the different, you have your samples in here, and more on that in like the crystallography stuff posts. For actually freezing the liquid nitrogen, we have these like little portable ones, as well as this one. This one's really good for if you have like 50 mil Falcon tubes when you're freezing down cell pellets. This is our plate incubator for the crystals. So this is like a robot, and it's actually going to take the plates with the crystal screens and take pictures of them so you can see if there are crystals forming. This is really helpful because then you don't have to do it yourself. I mean, you don't have to take them out and look at every well individually, which is a huge pain. This is a lot easier. Plus, you don't want to be like getting into the screens a lot, because the more you mess with them, the more likely that like things can happen. Crystals are really sensitive. Yeah, so this is what we ship the crystals in. We just like put these dewars in here when we want to ship them to the beam line. You want to be really careful with anything that has to do with heat or flame or fire of any sort. And so you might have seen one of these. This is a Bunsen burner. It uses like this striker thing here. It's connected to this gas line, and when you turn it on, then this gas, and then you strike, and then you get a flame. But you want to be really careful that there's nothing flammable in the area, and you clear the space and all this stuff first. So be careful. Next to the gas line is actually here. There's like a vacuum line. And so we can plug this into when we do like a vacuum filter. So we have this device that we stick on top of bottles, and then you put a filter and it like suctions things through. There's also an air line, and yeah, so I was confused how these work at first, but if anyone else is confused, you just like turn the knob so it lines up with the thing, and then make sure you turn it off when you're done. Another thing that can get hot is this heat plate, which I don't use really for the heat, which is why I like have it taped closed so that I don't accidentally press the heat knob. And I also leave it turned off so that I don't accidentally have it on. But then the stir bar, so it's basically, it has a magnety thingy in here, and then you put a magnetic stir bar in your flask, and then you can adjust the stirring, and the stir bar will stir in your glass. And if you turn it on and you wonder why nothing's stirring, you probably forgot to put in the stir bar, which happens all the time. So those are a couple things on my bench that I had forgotten to show you before. So also on my bench, you'll see there's a lot of like buffers and stuff. So that's like pH stabilized salt water, and I have like stock solutions of various salts. And buffers and stuff, so stock solutions where I have like a higher concentration of it, and then I can dilute it into various things. This is our, so now let's go to stuff for electrophoresis. So that's where we use electricity to send molecules like proteins or DNA traveling through a gel mesh to separate them by size. And so this is for agarose gel electrophoresis for like DNA. We have boxes for SDS page. They hook into, so that's for proteins, and they hook into these power boxes. Let's see, we have like balances. This one's like more accurate. It's got this little like shield thing to shield it from air so you don't have interference. So we have like weigh boats in different sizes, as well as weigh paper. What I like to do with this paper is actually like fold it so there's a crease. And this way, when I'm like weighing things out, then I can weigh it on the paper and then kind of just move and transfer and pour it. So, yeah, we also have this where you can then like put a tube in it if you're measuring things out like that. We have a shaker platform, an illuminator tray, so you can like look at your gels. We also have like a gel dock scanner thing that you can actually take pictures of your gels. So we actually got like, and it has a transilluminator for like UV stuff. So we actually got a new one recently, which is pretty cool. And so yeah, so it actually has this like tray, and you put the different trays in. So it's a lot higher tech than our old one, which is good because our old one drove everyone crazy because it took like 5 hours to focus. This is a Typhoon scanner. You can put like phosphor storage screens for radioactive scans, like those screens that you put on and they capture the radioactive signal given off, and then you can scan it and see where the radioactive things were in like your gel or whatever. More on that in the radioactivity post. You can also put in a fluorescent tray if you have to do a fluorescent scan, such as if you have like a cyber gold stain gel or something like that. So these thingies, those are carboys, and so they're just like big, kind of like you might see at like a sports event where you have like a thing of Gatorade or something where they have a strippy thing. Here we keep a big tube in that thingy too for like sanitizing, like disinfecting like bacterial or insect growth media. So like the food that we grow the cells in, we pour some bleach in there, we let it sit to disinfect everything before we actually like dump it down the drain or anything. This is just a plate incubator for bacterial plates. It's probably hard to see with the shadow, but yeah, and always remember to put your bacterial plates, so put your petri dishes upside down so that the condensation doesn't fall on top of the plate. This is a sonicator. We use it for like breaking open cells and shearing the DNA when we're doing a protein purification. These are agar plates, so we can grow bacterial colonies like when we do cloning and stuff. And so the dishes, there's like petri dishes, and then we fill them with agar, this just like sugary gel mix, and then some antibiotics typically because we're doing selection. And then we can grow bacteria there. Agar is pretty cool because you can like melt and re-solidify it into the plates after you autoclave it. This is like some of our pre-made bacterial media. So we have a media maker who is amazing. And so she makes all this various media, and then she sterilizes it in an autoclave, which is like a big high pressure steam cooker oven thingy that's going to like sanitize everything. So that's at the end, and here's like these like dishwashers, and so things go in the dishwasher, and then they go in the autoclave, and then they go in the drying oven. This is like a milliQ water purifier, and so that carboy I was showing you by the sink in our lab, that actually has water from there. So she fills those for us and like delivers them, because the milliQ purifier, it makes water really, really pure, but it's really, really slow. And so it's helpful to have just like a big bucket, like a big thing of it that you could just pour out of, instead of having to wait, drip, 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 drip. Yep. There are a lot of different types of water that we use in the lab. And so when you look at a faucet in a lab, typically on the right is going to be like normal tap water. And on the left is going to be distilled water, DI water. So this DI water is good enough for some things, but often what we want even further purified. And so we have like this milliQ filter system that's actually going to further purify out this water. And then we can use this for our experiments. If we need super duper pure water, we want to make sure that it's like free of RNAs. So it's free of RNA chewers and DNA chewers and that sort of thing. We buy these little bottles of water, which are like BioPerformance certified. You want to make sure that these, like, they're only clean until you open them. So you want to make sure that you use care when you're using these, so you're not like introducing stuff into them. If we want to measure the pH, we have a couple of options. So this is like our pH meter. So this is if we're doing like a solution. You put this tip in your thing, and then it'll measure the pH, and then we have like standardization buffers that you do first in order to calibrate the machine. If you just want like a quick look, you can use a pH strip, Obviously not quite as sensitive, but it's good if you just need to like dip in and see if the pH looks like it's about right. Sometimes if you're having problems with an experiment, you might want to check and say, okay, well, is the pH like super duper off? Because then that could cause the experiment to not work. So pH strips, you just stick them in. Then you might have used something similar if you had like a pool or something like that. This is our cold room. This is my least favorite place in the world, but look at all those boxes of insect cell media we finally got. So exciting. It was back ordered for like 4 months, and we were having to try like making media from powder and all this stuff, and that was not fun. Since we're a structural biology lab, we do a lot of protein purification, and so we do a lot of that in the cold room and also with our actives that I'll show you in a minute. But we also do some like crystallography and cryo-electron microscopy, or at least my lab mates do cryo-EM. I did some crystallography, but I haven't done it in a while. But this is our crystallography room. So we have like robots, machines called mosquitoes that can actually like help us set up drops, which I've done the post on that, but basically trying out a bunch of different conditions to get a protein to crystallize so you can take pictures of it. And the way that we take pictures of it, well, they're not really pictures, but they're diffraction images. So basically you shine x-rays, and then the x-rays interact with the atoms in the protein, and then they scatter those x-rays, and then they hit a detector, and they get measured, and then you work backwards from this pattern to spots called the diffraction pattern, and more on that in the crystallography posts. But this is our home source, and so it's not nearly as powerful as like when we want to actually collect like high quality data, where we go to a synchrotron, which is like a super powerful beam line that does way more than just like X-ray crystallography stuff, but it's really powerful, and we go there for that sort of thing. This is the cryo-EM. And so, yeah, I don't do this, but this is our big Titan Krios. More on that in another post too. This is my favorite place probably. This is our purification room, our active room. We're so fortunate that because we do so much purification, we have like 4 actas. So each of those columns, we have different types of columns, and they have different types of resin in them. And so resin are these like little beads. And when you flow a solution containing proteins through the resin, so in that column, the proteins are going to interact differently with the resin, and so they're going to flow through at different rates, or they might get like stuck, and then you add a competitor to unstick them if you're doing like affinity purification. But basically they're a way to separate various proteins based on their properties and how that makes them interact with the different resins that are in there. So it has all these lines, and you stick it through, and then the protein goes through the column, and then it goes through into this like fraction collector and goes out into a fraction collector. And so I have a post on using the actas and the different parts of the actas and stuff in a different post as well. Chromatography, we also do gravity flow a lot, so we have a bunch of different sized columns depending on our purposes. I typically use like this size of a column, and then you just clamp it on to a little holder tubey thing like that, and then you can flow your sample through, taking advantage of gravity. And we also have PCR machines, which we've talked about before. This is a real-time PCR system for like qPCR, and so it has this detector in it that's actually going to measure the fluorescence as you're doing your qPCR assay. It can also do like thermal shift stuff, some cool stuff there. Okay, lab tape. I love lab tape. We have it in a bunch of different colors, and some people don't take advantage of the colors, but I like to take advantage of the colors, and especially if I'm making the same like varieties of buffers a lot, then the color coding helps me know what's what more easily. We use epoxy glue for like when we're preparing crystal tips, putting the crystals pins like into the little puck thing, into the little like magnetic thing that we put into the pucks. Yeah, but basically we have epoxy glue, so it's on the slide. So then we just have basic office equipment things to come in really handy, like a calculator. We waste a lot in the lab because we have to, but so try to reuse whatever you can in creative ways to make little like storage containers and that sort of thing. Finally, although a lot of this stuff might seem foreign, there's a lot of stuff in the lab, that is stuff like you'd find in your house. And so we have a bunch of foil, which we use to keep light away from light sensitive things. So anything that's like fluorescent or that sort of thing, you want to keep it away from light so it doesn't get like overexcited and lose its fluorescence and all of this stuff. So you keep those foil wrapped. We have saran wrap for wrapping gels and that sort of thing. Lots and lots and lots of salt, sodium chloride. Microwave, good for when you're preparing agarose gels or that sort of thing. Then we have funnels, bleach, cleaner. Fantastic's really good. We use this in the hot room. It's really good for when you're trying to clean up like things and make sure they're not radioactive. We use Rain-X. So Rain-X can be really useful when you're making those really big gels and you want to make sure that the gel, like nothing's sticking to the gel, and so that your gel can come off of the glass and not get stuck and then you rip it and all sorts of stuff. So you can use the Rain-X to like coat the glass when you're cleaning it before you like put the gel in between them. And yeah. Okay, so that's some stuff you find in a lab. Now go enjoy.